Alright, so I have this fake battery adapter for my Sony a5100, and I was thinking, yeah, it's great, just maybe I just need an extended battery and not have to plug this into mains. So yeah, I figure I'll just make a little battery pack adapter for this thing. So I was looking through my junk bin and I found, well, this comes with a proper barrel jack that fits into the adapter like this. So I'll just snip this somewhere around here, and for lack of anything better right now, I'll just use Wago quick splice connectors to connect my also very DIY battery pack to this. It's just a couple of 18650 cells that I had laying around. I do have one of those LiPo RC batteries somewhere, but I just can't find them. And also I can't find my charger, so I'm going to have to just charge them using my bench power supply. But it should be fine. We're doing this for convenience in the lab, not for anything too fancy, so whatever. So let's get started. So the Nikon takes, two lithium cells in series, so this should be fine. We're not going to have any protection, obviously, but the camera itself will shut down at a low enough voltage level, so that should be alright. I know people say not to solder battery connections, but that's what we're gonna do, because I don't have a spot welder, and what would be the point? It's just, I'm gonna do it real quick with the welder over here, so it's not gonna hurt that much. So yeah, let's do that. Let me get some tape to secure these batteries together before we start. Alright, that'll do. So let me see if I can get you in here. Alright, let's add some little flux to it. Alright. Well, snip a little bit of this silicone insulated wire. Alright. So we need about yay much. Create our series connection. I should also add the center tap just for monitoring, and so I can charge it well, in a sort of a balanced way. And I'll probably do that. I'll probably just tap, let's see, tap another wire off the end here. Let's do a different color though. Let's go for yellow. Let's get some yellow wire here. So it's just these together. Now let's do our bridge here first. Alright. And that's bridged in, and we'll add a little bit of solder to this. Just move in quick, right? Hopefully it won't blow up on us. Alright. Alright. Blow on it for good luck. Let's pre-tin this end. Alright. It's stuck on there. And now we left it just a little bit too long. Alright. And we'll just go in real quick, right? There we go. It's in there. Soldered, it's not going anywhere. Now, for the other side, our actual 8.4 volts is going to come out. Just get some red wire. Just like that. Now let's get a little vise to hold this. That should do. Alright. Some flux on there. Tinning in. There we go. Let's pre-tin our little lead over here. Pre-tin. And it flowed. Do the same for the negative side. There we go. Pre-tin this. Alright, now let's stick it on. There we go. It doesn't take long. The batteries are going to be fine. I do want to replace this Kapton tape with something more sturdy though. There'll be people screaming at me, why don't you use a 3D printed holder? Why don't you buy a holder off whatever? No, I just need this right now. I only got 39% battery left while I'm filming this, and I'm pretty sure it's not gonna last me very long, so looks like a fucking bomb. Don't take this with you in an airport. Alright, and the idea is so we can easily replace this battery, well, with something else in the future. I'm just gonna use these quick connects from Wago, right? There's a spring clamp inside, perfectly safe. I've only got the 3-gang version on me right now, so this will have to do. Okay, now let's look at this and see where our positive, negative goes. And it's kind of weird because the connector for the camera does have what looks like the center tap connector over here. Could be something else, could be the center tap, I'm not sure. Let's look inside and see what it is. If it's the center tap, if they just faked it with a little resistor divider in there, then I'm just going to add the center tap, because why not? If not, then it's something else, could be a thermistor input or something like that, and we'll just leave it alone. But I need a Torx bit for that, so, alright, what does this look like? T8? Yeah, it's a T8. Right, so what happened just now was the camera overheating and shutting down. This does tend to happen. I found it happens less with the fake battery inside, so hopefully this will help too. Alright, so I need to get the polarity of this thing right. So right now, let's just cut off this piece of... Alright. And strip this a little bit. Alright, let's see if you see this properly. So this is the bit that will go inside the Wago quick splice. And before we do that, we got to check, you know, what our polarity is for these jacks. But also, I said we were gonna, excuse me for a second, I said we were gonna check the inside of this thing, right? See what it looks like. Oh, it might be welded. Is it? No, it's not. Alright, something broke. Oh, it's quite a complex piece of circuitry in here. It's not as simple as I thought. That's a bummer. So what do we have here? Let's see. So this might just be a little, what is this? L plus, L minus. There are the markings on there. And then there's this blob I see over here, and what looks like either transistors or some sort of voltage regulators. And a bunch of resistors, a capacitor. That's interesting. This might not be as easy as we thought. Let me check the original adapter, see if it's AC or DC. Right, so this is the original, the fake battery adapter, and you can clearly see the output is DC, 7.6 volts at 2 amps, which is, you know, middle of the range for halfway discharged lithium cell, 2S lithium battery. So this is interesting. Why do we have all this crap in here? Is it just to trick the camera? Is there some communication going on, and this is actually tricking the camera? Could be. It could be. I mean, we can try removing this and seeing if the camera will let us talk to it. Well, see if the camera will let us charge it without this piece of circuitry over here. We could take a look at this under the microscope, but I don't think. I mean, yeah, I'm pretty sure it'll just work, but I'm not sure about the center tap here, the our third terminal over here. Well, let's try it, see if it works with the battery, and we'll take a look at the circuitry later. All right. So, according to this adapter, the center is positive, the outside is negative, and we could probably check that fairly easily. Let me get some probes in here. So, these are some nice needle probes, and all right. If we probe on the outside of this thing, and then here, yeah, that's fine. And then center is going to be this. Yeah. And if the markings are correct, this is positive, this is negative, red and black, standard. All right, let's check our other jack and let's see which one is positive, which one is negative. So, now this lead. Got it right on my first try. Okay, so this is the negative lead, and we'll hook that into our battery here. Right. There we go. There we go. Okay, and now if I plug this in, you know, it shouldn't blow up, and it didn't blow up. So let me try putting this in the camera, and I'll let you know if it blew up or not, because I can't film and, well, I can film after I start it, but I'm not sure what the charge state of this battery is, so let me see. I'll do a quick check. this, and this. 7.12 volts, reasonable enough. It should start. So, be back in a second. If I'm not, then it blew up. So it did turn on. Unfortunately, the battery is very discharged, and I'll have to charge it. It's been sitting in a drawer for probably like 2 or 3 years. So I'll charge this battery back up, see what it does. It does. The camera does turn on, but it immediately just shuts down because the voltage drops below like 6.5 volts. So, yeah, it'll do that. But all right, so we've got a winner. But then there's still the mystery of what the hell's up with that all that circuitry in there. So we'll try to figure that out after that. Okay. Catch you later.